provision. Okay, the recording has been started. Let's begin. I'm switching off my camera and sharing my screen. Today's lesson will be quite challenging because we are going to use Azure, or not Azure, we are going to use Amazon Cloud and Terraform to provision our Jenkins. So please look at the diagram. What we are going to provision. Firstly, we need to provision VPC. Then we are going to provision subnet inside only one availability zone. It will be enough for our task. Then we're supposed to provision EC2 instance attaching to security group, which will allow HTTP and SSH connection from outside, and to be reachable to internet, we need to add the internet gateway and route table. So let's start. First of all, I would recommend you to create the directory. For example, make dir Jenkins AWS. And I'm going to use Visual Studio Code as a text editor, and I will open this directory. And here we are going to add manifest files, state files for Terraform to be able to provision our infrastructure in cloud. So what do we need first? First of all, we need to provision basic network environment in AWS cloud. So we're going to create VPC first. Let's create a new file and call it network tf Terraform. And let's start filling it with resources. Of course, first of all, we need to create resource VPC. I will call it VPC1 with the CIDR block, which will be defined in a variable. It will be a bit later. And then there will be some tags. It's up to you which to use, but here I will use name, Terraform, and environment. So next, as we define it, then we need to define subnet inside VPC. It will be look like this. AWS subnet resource, which is called CIDR1. It will be provisioned inside the VPC ID, which we take from AWS VPC1 ID. Then we will be using a cider block as defined in variable, and of course we'll use some tags. So next, what is needed for basic network infrastructure? We need internet gateway. It looks like this. We'll call it just gateway 1, and it will be inside VPC 1. And then we need resource row table. Row table is called RT1, and it is also inside VPC that we define it at the first step. And I will do. And there is a route which is defined that everything, it means everything, we are going to route to AWS gateway with the name gateway 1, and here it is the internal identifier. And of course, this field is optional, but with some tags, it looks more professional. So we will keep use tags. And we need to associate our railroad table to subnet. And there is a special resource for this task. It's called AWS Route Table Association, and it is called CIDR1 RT1. And here we define our subnet ID and route table ID. So subnet ID is AWS subnet with the name CIDR1, and route table ID, route table with the name RT1. Here it is. So that's all for basic network infrastructure. Let's save it. And what do we need else? We need to create one more file with variables. Let's call it parse.tf. So what should we use here? As you can see, there is a project name variable which is used. So let's add it. And our project will be called Jenkins. Then what else should we install? VPC cider block is also is needed. We will use this subnet 10.0.0.0, and what variables we are using also. Of course, availability zone should be defined. I'm going to use EU Essential 1A. And let's look what it is needed. And when we're creating subnet inside VPC, of course, we are creating a cider block. It should be inside VPC subnet, so we should define it. And it will look like this. So this cider block is inside VPC. And next, project name. So looks like we define it all variables. and let's save this file. And what next is needed? Now let me have a look. Of course, we need to define providers. Let's get file with name providers. Providers.terraform. It's a special file for Terraform. So it looks like this. Usually it is all the same, so there is nothing to discuss. Let's save it. And what else should we use? So we have created VPC, we have created a subnet. Let's check. VPC, subnet, internet gateway. We have created route table, and we attached route table to a CIDR block to a subnet. And also we need to create security group for future EC2 instance. So let's create new file, and for example, let's name it security. And inside security, we need to create a security group for EC2 instance. So here it is. It's AWS security group. It is called EC2. It's inside the VPC that we define it. And the egress rule allows everything to internet, and ingress rule will be allow some special ports to be allowed. And there is an option to define each port, but if you have multiple ports, the configuration will be quite long. So to be shortened, there is the special function for each. And inside for each, we can define from port to port, protocol, and CIDR blocks. And now we have to define ports for which will be available for EC2 future EC2 instance from internet. So going to var directory, and here let's create a new variable, a ports EC2, a list type, and which ports we are going to be used. Let's think about it. Let's use 22 and 8080. I suppose it's enough. Let's click save it. And so I suppose it's enough for the initial installation, and so let's run it. For this, we are going to the directory which we just created. Here are our files, and let's run. Okay, it was initiated successfully, and now we have to apply it. I suppose you know the command Terraform apply. first it will check our manifest, and then if there is a mistake, it will highlight it. So there is a mistake was found. Let's have a look. Oh, no valid credential sources for, I didn't provide it credentials. One moment. I have to enter some keys, AWS access key and AWS secret access key. I have input my credentials, and let's try it again. Perform apply. Yes, here is our plan, what we are going to provision. So let's have a look. It is AWS Internet Gateway. It's AWS route table. It's a route table association, security group. Here you can see that instead of only one block, we have 2 blocks for port 22 and for port for web access 8080. And here we have subnet, CIDR 1, and VPC. So let's create it. Yes. So while it is created, I will show you that I removed all my resources, and at our lessons we are going to use VPC, EC2, Route 50C, Identity Access Management, Bucket, Certificate Manager, and I don't remember, maybe a Secret Manager will be also needed for us. So as you can see, there is no default VPC in my account, and now they are going to be created. Let's refresh. Okay, now we can see that VPC has been created. It was created with default access control lists. The route table was added, Internet Gateway, and what else? Let's refresh page once again. Okay, everything is completed. 6 resources has been added successfully. So where we are? So what was done? We have provisioned basic network environment for our future Jenkins instance. Now we need to create Jenkins itself, and we will be using Terraform EC2 instance for Jenkins. So let's create EC2 instance manifest. And let's create new file and call it compute.tf. First of all, before defining EC2 itself, we need to define operating system which we are going to use. I would suggest to use Ubuntu. It's free, and so this is just a resource which return you data about OS Ubuntu, and we choose this version 20.04, and we have filtered for virtualization type HVM, and there is the special field owners could be found in AWS portal. Then to be able to access to our EC2 instance, as you remember, we need SSH key pairs. And there is a special resource, which is called AWS a key pair. I will call it a key pair 1. And I'm going to use public key, which could be found from the file, and file name is a variable. And now we are going to define this variable. Okay, go to vars. Public key pass. Here we are defining public key pass, and my public key allocated in home SSH IDRSA file. This is the default location in Unix systems like CentOS, Ubuntu, or Mac OS. And a bit later we will be needed to define also private key paths. So I defined it also. Okay, then compute. Then we are going to create a resource itself. It's AWS instance. It is called instance 1. So it's not needed now. AMI, it's image which we'll be using for this instance. We define it here, AWS AMI Ubuntu IDE. Instance type will be T2 micro for the first time. Then VPC security group ID, we have already defined it in security manifest. And we're asking to associate public IP address to our EC2 instance, subnet ID, and key name as our key pair ID. And what else is needed? Then we are going to, if we run this instance, it will be empty instance without anything. And we are going to use user data option, which allows us to load some script which will be run at the start of the instance. So it in our user data, we will define how to install Docker, how to run Docker Compose with Jenkins, and so on and so on. We will look at it a bit later. The next part is the connection. we are going to use user with the private key. Of course, we are going to define EC2 user. Actually, the connection tab will be used at the upcoming lessons, but we can redefine it right now. Don't pay much attention to this field. And of course, to look more professional, we're using tags. And we need to define EC2 user. Words. And our EC2 user will be Ubuntu. So let's save. And let's save this also. So what we need to define also all together with EC2 instance, we need to create user data. We need to create key pair, private and public. To create key pair, there is a utility SSH key again, but I will not use it because I have already created and I don't need it. But if you need to, you can run SSH key again and press enter, and your public and private key will be generated. So, so we need to create this file. One moment. Let's create user data file. It will be called user data instance 1. And let's remember what was we using in our previous lessons for Linux to run Jenkins. There will be a slight difference, maybe big difference. Actually, at our previous part, we used CentOS, and now to show how to use Ubuntu, we will be using another system. It will be Ubuntu. So let's create shebang bin bash sudo get update to update repository, and then we need to install Docker first of all. So before installing Docker, we need to install some tools which will be useful later. It's a regular like CURL, certificates, and so on. And there is a quote how to install Docker. I took it from official Docker guide, and there is one moment that when we are going to run Docker image from Ubuntu, we are going to add Ubuntu to a group Docker. It won't work if we do it. So we need to add Ubuntu to group Docker. So it should work. Forget one line. So next we need to create a Docker Compose file. It could be done this way. Get from this before end of file inside a Docker Compose YAML, and we're going to use port the same as in Docker container 8080, and here you can see stuff you was already used before. We're going to start a service which is called Jenkins from the container. Container name is called my Jenkins from image Jenkins, and we are going to use Jenkins home directory for saving a configuration on this machine. So of course we need to create this Jenkins home directory first. Let's create it. Make dir Jenkins home. So I suppose it is better to define a full path from Ubuntu Jenkins home. And let's change the ownership to Ubuntu. And Ubuntu will be used the ID 1000. It will be the same like in Jenkins. So there is no need to change ownership from Ubuntu to something another. Ubuntu is using the same Linux identifier. So, and of course, then we need to change directory to home Ubuntu and run command docker compose app -d. And what I'm going to install also is just if there will be some mistake, just to find out what was wrong. We will be keeping steps in our log file. So, for example, here it was Docker installation, and it finished here. Let's insert this log, for example, Docker. Docker has been installed. And then let's call this ownership was changed. It's changed. And here. Docker compose file was created, and then instead of done, something like Docker. Okay, let's save it and check what is needed. So it is needed to create EC2 instance manifest. Then we created user data for EC2 instance install Docker and Docker Compose, and also to create a manifest Docker Compose with Jenkins and running this manifest. So let's proceed with the Terraform. Let's go to console and Terraform apply. There is something is wrong. Line 37. There is no bracket. There should be a comma. As a template file, it is needed to use some environment with some variable. Let's try just for text. Line 37 still has error. Okay, let me have a look. One moment. Let me try once again. No success. Okay. That's we are going to do. Let's check. We are going to add EC2 AWS instance. And what else? A key pair. And that's all. Let's click yes. Okay, there are 2 resources added. Let's have a check, and I will update my AWS Web Console. Let's go to EC2. Here we have one EC2 instance running, one SSH key pair, and let's check it. EC2 instance 1. Yes, it's initializing. And of course, I forget one moment. Here is the public IP address of our instance. It's not very comfortable each time to log into web console and look for public IP address. So let's create user output with the public IP address while it is loading. For this reason, let's create file, how to say it, output.pf. And inside output, let's output EC2 public IP address. In description, no, it's description EC2. That's okay. And let's run Terraform apply once again. Now it will check there is nothing to be added, but here you can see output with the public IP address. And if we run it the first time, we will see our public IP address, and there is no need to go to the web page and look for public IP address here. So let's check, and 8080. Oh, that's great. We just provisioned Jenkins in AWS cloud using Terraform. That's great. So, where we are with our plans for today. So what was done? We have created network infrastructure, we provisioned Jenkins in cloud, and of course, I would like to show you that it's not enough, because when we log it in, let me log in to it. So here logs. Here is our initial administrator password. Let's continue. We are not going to install any plugins. As you know, it works quite well. So you're very familiar with this stuff. So, okay, great. We just provisioned Jenkins, and let's imagine that something went wrong and we have lost our Jenkins instance. And so, for example, let's destroy something. Let's not this field. Let's destroy AWS instance with name instance1. So we can see the compute AWS instance1, and after proof, just to make it a little bit faster. So there is a plan, one resource to be destroyed. Okay, that's great. One resource is destroyed. Let's check. Okay, now there is nothing behind this IP address. And let's create it once again. Terraform apply, --. Auto approve just to make it faster. So this IP address is not we are going supposing to use. It's the old IP address, and here is the information that will be known after apply. And we have new instance with another IP address. I suppose we have to wait for some time for instance to install Docker Compose, download Jenkins image and run it. Let's wait a little bit. And what we have here, we have new instance. It is initializing. So let's wait a little bit. Okay, Jenkins is getting ready. Let's wait a little bit. Mm-hmm. And the status is running. Okay, and what happens? We removed a Jenkins instance, and for example, something happened, a server was damaged, and we lost all our settings. There is no user, and we are again with a brand new Jenkins. And what should we do? How to avoid this situation in the production or in the future? One moment. Let me show you one diagram. EFS file system will help us. It is quite reliable file system, and we can keep Jenkins home directory in this file system separately from EC2 instance, and whatever will happen with EC2 instance, all our settings data will be saved inside the EFS file system. So we need to provision EFS, and the second step, we need to mount EFS to EC2 instance. So let's try to do it. So we need to create EFS volume. for maybe 1 gigabyte will be enough. And we will create new file. Let's call it storage. Storage.tf. And let's create EFS resource, AWS EFS file system with name EFS1, and performance general purpose, and of course with our tags. And it's not enough. Also, we need resource as a mount target. We have to mount this EFS file systems to EC2 instance. So this is a file system ID equal to this resource, and it will be inside our subnet, CIDR1, and we need to add security group, of course, for this resource, as it is a network resource. So let's save it and go to security. And here we need to add one more resource. And it will look like this: egress from any, and egress will be loaded from as ingress. We allow any instance which is connected to security group EC2 with the ID of it, and to port 2049 and TCP. So it's quite challenging once again. And the ingress rule defines that we allow a connection to port 2048 from any resource which is connected to another security group. Okay. I hope it's clear. So let's save it. And what else is needed? First of all, let's remove our EC2 instance. Let's destroy it. Okay, it will be destroyed. And we need to change EC2 user data to attach EFS volume inside the EC2 instance. So what do we need to be able to attach EFS file system? It is useful to use EFS utils from AWS. So let's clone EFS utils and cd EFS utils and run some script inside EFS utils to be installed. Here we're going to mount EFS to Jenkins home directory. I have noticed that after mounting, there could be changed but who's the root owner of the directory, and we'll change it back to Ubuntu. And I would like to move this to the end, and let's call it EFS. Mounted. And here is the variable, which is called AWS EFS ID. We need to know it, but how we can know it? We can know it from the storage. So we need the output with this variable. We need to know this ID, EFS ID. So one moment. That is why I have left a special field. Here we can define this variable, and it will be EFS file system, EFS1 ID. So this is the way how we insert Terraform variable inside user data. Its a function is called template file, and it render our template file with variables defined here. And I would suggest to move it to looks a little bit better. Yes. Let's save it. So what was done here? And okay, let's run. Let's check that EC2 instance was destroyed successfully. No, not yet. Okay, then there is no answer, and we have seen that a resource was destroyed. I suppose it is destroyed successfully. So let's run Terraform apply once again. And here was our plans, what to add. First of all, we have created a file system. Then we are creating mounting to instance and creating instance. And also adding security group for a file system. Oh, seems I forget one thing. It is here. Let's edit. It could be useful because first of all, we need to provision EFS, and then we are provisioning instance. So let's add it to our infrastructure code, and let's have a look to console output. Everything is still creating. Okay, resource has been created. So let's check it a little bit later, because while it is installing all the stuff, it will took some time. And here is output of new IP address. I suppose it's time to check. Okay, Jenkins is getting to be ready, and let's connect with SSH. So I suppose it was not mounted yet. Mm-hmm. So let's check whether block storage was created successfully. No. Okay, Jenkins EFS was created successfully, but I don't see that is mounted to Linux. So let me have a check. User data. Let's check the log output. Yeah. Log. Oh. So let's do it manually. Oh, there's no directory. Yes. Let's mount it manually. We have found to ID. It will be found from here. I'm not sure, but let's try. Okay, let's have a look. Nothing has changed. Let's check to output our file system ID. AWS ID. Let's get this value. Okay. And when we run Terraform apply once again, we will see the output with the ID. Okay, it's the same as here. So the ID is correct. Well, let's mount it once again.